Welcome back to this channel for practice problems for actuarial exams. This is an exercise for exam FM on financial mathematics. And if you become interested in this exam FM information and the exercise, you can purchase my study manual for exam FM at smarturl.it/btdt-fm. And if you would like to make a donation to support the actuarial program at Illinois State University, where I'm the program director, you can go to smarturl.it/help-ISU-actuary. Here is the problem. Seth has two retirement benefit options. His first option is to receive a lump sum of $374,500 at retirement. His second option is to receive monthly payments for 25 years starting 1 month after retirement. For the first year, the amount of each monthly payment is $2,000. For each subsequent year, the monthly payments are 2% more than the monthly payments from the previous year. Using an annual nominal interest rate of 6% compounded monthly, the present value of the second option is P. Determine which of the following is true, and all the answers are about comparing P to this $374,500 lump sum, so we just need to find out what P is and then compare it to the lump sum amount. So the trouble is that there are level monthly payments each year, but then they change every year. The frequency of payments is monthly, but the frequency of change is annual. Not compatible makes it a bit difficult. Also, the interest rate given is really effectively a monthly interest rate. It's 6% nominal annual compounded monthly. That's really 6% divided by 12, or 0.5% per month. What is the corresponding annual effective interest rate? Well, it's 1 plus 6% divided by 12 to the 12th minus 1, or approximately 6.16778. I'm going to call this interest rate I. And if we have a monthly payment at the end of each month of X, then this is equivalent to an annual payment at the end of the year, which is the accumulated value of those payments of X. And they are paid at a monthly effective rate of 0.5% over 12 months. So that accumulated value at the end of the year is X S angle 12 at 0.5%. So we can actually have annual payments that are equivalent to what we have, and then do the calculation based on that. So we do this calculation. Now the amount paid monthly the first year is $2,000. And the accumulated value of it at the end of the year, which would be an equivalent one-time payment at the end of the year, is 2,000 times S angle 12 at 0.5%. The second year is 2,000 times 1.02, and so on. The last year it will be 2,000 times 1.02 to the 24th. And otherwise, we need to discount by one more year every year at the interest rate I that we figured out. Okay, well then we see that this is the same as we put in front the common factor of 2,000 times S angle 12 at 0.5%, and inside we have 1 over 1 plus I plus 1.02 over 1 plus I squared, and so on up to 1.02 to the 24th over 1 plus I to the 25th. We remember now what I is, so substitute that, but then we also pull 1 over 1 plus I in front, so that inside we now have 1.02 over 1 plus I to the 0 plus 1.02 over 1 plus I to the first up to 1.02 to the 24th over 1 plus I to the 24th. This is a partial sum of a geometric series, and if the quotient of a series like that is R, this is like R to the 0 plus R to the first up to R to the 24th, or 1 plus R squared up to R to the 24th. that is equal to 1 minus r to the 25th over 1 minus r. And the quotient, the ratio, is 1.02 over 1 plus the interest rate. So we use that information of what we have about the interest rate, and we use the partial sum formula for a geometric series, and we actually have all the numbers now that we need to do the calculation. And of course we do have to do the calculation of S angle 12, which you can do with a financial calculator. So this ends up being 374,443.38, and the lump sum was 374,500, and the difference between the two is about 56.62, or about 57, which is answer D. Please remember, this is copyrighted material. The problem originates from the Society of Actuaries, and the problem is theirs. The solution I present you is mine. Good luck in your studies, and good luck on the test.